So we're trying to show that any Boolean formula can be transformed into a graph such that this graph has a large clique, in that case only if the Boolean formula has a satisfying assignment. And here's one fact that's going to make our life a little bit easier. Every Boolean formula can be written like this. So you have the brackets around variables that are only combined by ors. So you have variable 1 or variable 2 or variable 3. And you can have more than 3 variables in here. But you have nothing else. You only have variables and ors. And between the brackets, you always have an and. So you have bracket of ors and bracket of ors and so on. This is known as the conjunctive normal form of a Boolean formula, and it can be shown that you can write any Boolean formula, no matter how complex, in this form here, and it will not significantly change the size of the formula. So if you have n variables and your Boolean formula has size polynomial in n, it will stay that way if you transform it into the conjunctive normal form. And if you have conjunctive normal form, then this part here in the brackets is known as a clause. So this here would also be a clause. And what you can see is the way that this is structured. The Boolean formula, if it has a satisfying assignment, then each of these clauses needs to evaluate to true, because they're all connected by an and. So if one of these would evaluate to false, then the whole formula would not be satisfied. Now, how are we going to transform this into Clique? So I'm just going to show you how to transform a Boolean formula that is written in this form into a graph, and then we'll discuss what this has to do with Clique.